Guys, this is question number 7 of the same worksheet. I think it's the same lab that half of you done today on Saturday at tuitions. This is K1 of 4 SFV1 given as 0.023 moles per dm cube and an ethane dioic acid, which is a hydrated salt whose concentration is what you need to find, I guess, because they haven't given it to you. It says here you need to find the concentration in grams per dm cube of FB2. And the first thing you do is you dilute FB2. So we know that dilution is important here. I've given you the volume for dilution already. It's 43.00 in 250 cm cube. And that solution is now labeled as FB3. So FB3 is the dilute ethane dioic acid. FB3 is that. Now moving down, we titrate FB1 with FB3 right here. If you're the second pair with FB1, that's K1 of 4. You take 25 cm cube of FB3 in a conical flask. You add excess sulfuric acid and water. They're just there for in excess as conditions, not need for calculation. What you do need at the end is the titer volume, which is 24.25 cm cube. Now I won't discuss the lab, but it's just the calculation today. So on the next page, this is what you have to use. This is the average volume of part B, 24.25. When part B, it says from the titration results, obtain a value for FV1, that is the previous value, which is previous page 24.250. So let's move forward, and there should be 24.25 cm cube. From this, they want us to calculate the moles of K1 of 4. Simple calculation that is, because this number of moles is equal to concentration into volume. The concentration is from the previous page. I'll move up to get that. I think it was 0.02 something. Let me see. Crap, a little slow. Yeah, 0.023 for FB1. So it's 0.023. And the volume is the titer volume. So this is your titer, because that was K1 of 4, which happens to be 24.25 over 1000. And you get the number of moles. How much is that? Let me close this. Okay. 0.023 into 24.3 divided by... No, I'm sorry. I forgot the values. Let me go back. 24.25 and 0.023. So 0.023 into 24.25 over 1000. That's 5.5775. 5.5775. Where is that? 5.5775 into 10 to the power of -4. You should have gotten that. That was pretty simple. 775 into 10 to the power of -4. That was the easy bit. Now they've given us to balance an equation. How does one do that? First, they want us to put the correct number of electrons in each half equation. You do that by looking at the charge. This side has a +2 charge. This side on the manganate has 8 plus and 1 minus. That is +7. And this is +2. So electrons have to be 5. So +7. So 8 minus 1 and -5 makes it +2, which is what it is here. On the other hand, this side ethane dioxide has -2 and there's 0 charge here. So it must need 2 electrons. Now once we have that, to find the reaction ratio, the electrons have to balance. So 5 electrons taken in should equal to 2 given out, but they're not. So we balance the equations by multiplying them by a coefficient to get the electrons to balance. So this, for every 2 reactions of the first equation, you'll have to have 5 reactions of the second equation. So the total electrons become 10. 2 times 5 is 10 and 5 times 2 is 10. So the ratio of manganate to ethane dioate ions are 2 is to 5. That's important because that's how we find the number of moles of ethane diode. So the previous part will get the moles of manganate, which are 5.57. Let me undo that. Let me do it here. So 2 is to 5 and 5.5775 10 power minus 4 is to x, and the x goes here. Now that's divided by 2 into 5. So let's do that. Here's my calculator. So divided by 2 into 5. I get 0.0013994 or 1.3944 into 10 power minus 3 or 1.3944 into 10 power minus 3. That was simple enough. Now this was in the conical flask because they reacted with KMnO4 from the burette. So then they want us to find the concentration of Fb3, which is simple. Number of moles equal to Cv. Number of moles of ethane diode we know from the previous part. That's 1.3944 into 10 power minus 3. C is what you defined. Volume of Fb3 used in the reaction was the pipette volume. And from this we find C, and the value goes right here. And the value is into 1000 divided by 25. So divided by 25 into 1000. I get 0.055775. Oh crap. Undo that. I kind of forgot what that was. Let me see. 0.055775. 0.055775. Now they want us to find the concentration of the concentrated solution, which is Fb2. So from Fb3 we gotta find Fb2. How do we do that? I told you guys when you gotta change concentrations, use C1V1 equals C2V2 for dilution. So the left side is the concentrated one, which is Fb2, and this side let's make it Fb3. So what's Fb2? We don't know. Its volume we took as, I forgot, so let's go back to the previous page. The dilution volume, which is 43.0. Brilliant. So we got that. So the dilution volume was 43.0 over 1000. C2 we know from the previous part, 0.055775. And the volume, this is happening in the graduate flask. So the volume will always be 250 cm3. So what's the answer here? The C1 will become into 250 over 43. So it will be into 250 over 1000 divided by 43 over 1000, and the thousands cancel out. I get 0.3243. 0.3243. Once I have moles per dm cube, how do I convert to grams per dm cube? Well, moles per dm cube into mr will give you grams per dm cube. And what is the mr? The mr happens to be, for this one, is 2 plus 24 plus 64 plus 18 times 2, which is 36 for water. 36 and 64 is 100, 126 if I do my math correct. 36 and 6, 96, 100, 126. So it will be grams per dm cube will be the previous part's answer into 126. So I find that out into 126, and the answer is 40.8584, 40.9 as three significant figures. So we write that 40.9 grams per dm cube, and that's your answer.